Okay. Okay, I'm just gonna start over, guys. Sorry about that. Okay, so, right, so lists are a really convenient way for us to store many things in one variable. For example, here we have primes. This is a list of integers. And similarly, you can store other data types like strings if you want like individual words from like song lyrics or something. You could store each word in uh, different parts of a list. And this is the way you create a list. So again, you just have your variable name here and then equals, and then you use these brackets, and then you put in your elements, and you have to make sure that you separate them with commas, and that's it. That's how you make a list. Okay, so if you're to understand like what a list is, hold on, let me admit this person. So um, So a list, you can think of it as kind of being like a shelf, or like if you want, you could think of it as like a row of buckets. You can basically put something in each slot of the shelf, and you can actually add or remove things from the shelf as well. Um, so here we have the same list from the previous slide, just primes. So it's kind of like this, and you can see these would be like your five, like quote unquote, like shelves. We have 2 here, 3 here, 5, 7, 11. Okay, so what if we wanted to access one specific value in this list? So if you recall, we just named this list primes. So the way to get, say, the first element is this. You see primes, and then we have our brackets again and 0. So what that number 0 represents, so this is the little thing that might take getting used to, but instead of counting from 1 as we might normally do, in many programming languages, we actually start counting from 0. So this 2 would be the 0th element. The 3 would be the first element, 5 would be second, and so on. So when we put in this 0 here, it's really saying we're going to be taking the first element from the list. If we wanted to take this 3 out, we would say primes, and then we put the bracket, and we'd put 1. And then for 5, we would put 2, 7, 3, and 11, 4. And if it was any longer, if our list was any longer, it would just keep going in that pattern. So something really cool about Python lists is you can take not one, but you can take a whole chunk of a list. And that's what we're doing here. So if we wanted to take, say, from index 1, when I say index, I just mean like this number. So like this is the 0 index, first index, second, third, and so on. So we can take, if you look here, we would split our 2 indices with a colon. So with this line right here, primes brackets 1:3 says, okay, Python, can you give us everything in shelf 1? So this is the 1 index, 2, 3, except this second one is exclusive. So it does not include 3, but it goes up to 3. So therefore it would be 1 and then 2. So then it would actually give us a smaller list containing just 3 and the 5. And this is a little bit difficult to wrap your head around, but you can actually put in negative indices. What that does is it goes sort of backwards. So like this one is -1 index because this is 0. And if you were to go, pretend you could go this way, it would kind of like loop you back around to the other side of the list. So this is -1. This would be -2, -3, and so on. And what we did here is we said -2 colon. So you might be wondering why there's no number after the colon. But what this really means is that you're going to the end of the list. So this is the -2 index. So primes with the bracket -2 colon would be going from 7 all the way to the end. So it would be this sublist. That was a lot of information. Does anyone have any questions about that? No? Okay. So there are many things you can do with the list on top of taking chunks of them. So if we wanted to add something to our list, we can use the .append method. we'll be talking a little bit more about methods later on. So if we wanted to add the next prime number, we can say append primes.append 13, and we would now have a 13 added on there. Let's say we didn't want to add it to the end, but somewhere in the middle of the list. So we can use insert. So what this does is the first thing you see here is the index where you want to put your new value. And the second thing is the new value itself. So here, this is our original list. We want to insert it at index 2. So currently index 2 it would be 5, but we want to change that to 4 then. So we would then it would squeeze it in between and then shift everything down 1. And like Python does all the work for you, so you don't have to worry about like shifting anything. It will literally just put it in there for you. Similarly, or like the opposite really, you can remove something from the list. So if you put in the thing that you want to remove, it will literally just take it out for you. So you can see if we do primes.remove 3, we no longer have 3 in the list. And another way to do the same thing is you can delete a specific element using the del thing. So del primes 3 is referring to 7 because this is the third index, 0, 1, 2, 3, and it will just remove that for you. Okay, so that's a pretty basic overview of things you can do with lists. Christina, do you want to write some examples?
Yeah, so if you go to the REPL, okay. So just to practice what Vignesh just went over, if you all can see, we can just try and make a list. Oops, okay. And we'll set the list name with an equal sign, and we can just say, I want the numbers 1, 2, 3 in this list. And then just to play around with it, I'll have a print my list at the end here so we can always see what our list looks like. And you'll see if I run, it'll just print how a list looks. So let's make some changes. So let's try the append method and append like whatever number we want. I'll just append 23, and if we run, we'll see that goes to the end of the list. We can also try inserting. Say we want, say we want to insert the number 4 at position 1. So position 1 is again kind of the second position really. So the 4 is now in between the 1 and the 2, and it shifts everything down as Vignesh said. And just to show you guys an example, I'm gonna append another 4 at the end of the list. And to show you when you, oops, sorry, something went wrong with my. So I'm going to append another 4 at the end of the list, and you'll see that if we try and delete, I go my list remove 4, it's going to look for any 4 and remove it, but it's only going to take the first one. So you'll see only the first 4 will be removed from the list. That is freezing. Ignash, are you getting the same? Can you try running it? It's not letting me.
Yeah, sure.
It's either rough
Yeah,
or our internet.
I'm not sure. It is not.
Okay,
Nothing's changing.
But if we were to run, it would get rid of this first 4 because it only removes the first instance of that, like whatever you give it. But then say we wanted to delete, okay. Oops. I don't know why it just went and deleted code. Okay, there we go. So say we also wanted to actually remove by index. As you saw on the slides, you would say DEL for delete. And you can say
Christina.
yeah.
Wait, Christina, I don't see you typing on this thing.
Oh my god, why is it so glitchy? It says you're off the thing now.
I'm off the thing.
Yeah. But you're on it. Do you want to type out you want to just type out deleting something at index 2, for example?
Okay. Okay, so if we wanted to delete something at index 2, we would type in del and then my list, and we want to delete the second element. So we just put 2. So it should remove that for you. I'm not sure why it's not running. It is not running.
Okay, that's a REPL problem. Can you see me on it now?
No. But can you resend me the link? I'll like rejoin it.
You're on it.
I'm on it.
Here, I'll send it to you in the chat.
Mm-hmm.
Okay, so basically you'll see that the 4 would have gone away because we removed the first instance of the 4. Okay, is that, there we
I
go.
think so. Okay.
Yeah. And if you can see that now.
Yeah, this is better.
Okay, and the element at index 2 will also be removed because, which was the 3, because we said delete my list index 2. And now to just show you guys with all of this, we can try accessing different parts of the list. So you guys saw, like, we can print my list of index 1, and it should print out 2 because that's at the very first, that's at the index 1, because it starts at index 0. And we can also try printing from the end, like printing my list -2. As Vignesh said, it starts from the end, so that should print out 23 underneath it too. We can try printing out my list 0 to 3, so that should print out values at indices 0, 1, 2, not so 1, it should print out 1, 2, 23. So you can see it prints out like a sub list. And if you want to continue with, we can continue with the next part of the lesson. Do you guys have any questions about how lists work? Or things you can play around with it a bit if you want. I'm just going to comment it out because for our next part of the lesson, we're just going to work down here. Okay, so now we're going to go into for loops. So basically, for loops allow you to kind of do what they sound like. So they loop through a bunch of items. So in this example, if we say for I in range 5, I is just a temporary variable that's going to loop whatever's after the colon and indented after this line of code. It's just going to run that 5 times. So I is going to go from, it's going to be 0, 1, 2, 3, 4. So it starts at 0 and goes to 1 less than the range you give it, but that's still going to run 5 times. So in this case, we're saying for I in range 5, print primes of I. So it's basically going to print every value of primes, because we're saying print, the first time we're saying print primes index 0, then second time we're saying print primes index 1, primes index 2, and so on until we get to primes index 4.
I just want to add one quick thing to that. I believe last week you discussed how to write while loops. So for loops, they're equivalent to while loops and like what they're capable of accomplishing. Just to compare it to while loops, instead of this, you would have set like I equals 0 to the beginning.
If you're explaining that, yeah, there's a visual that may.
Oh, okay. Yeah, so instead of like incrementing it yourself by doing like I plus equals 1, you would be, the for loop kind of like takes away that difficulty for you. Okay. Do you want to say?
Yeah, so basically all for loops do, the keywords are for, and then you create a temporary variable, which could be anything, but we call it I. So I will only be used within this for loop. If I use I somewhere else in the program, it's a different I. So it's like local. So yeah, basically we went over this, but it's gonna run the indented code after the colon 5 times. So, and Vignesh, you just basically went, yeah, you want to go to the next slide. You basically went over this, but instead of creating like with a while loop, that I, you can't use it anywhere. Like if you used it somewhere else in the program, it would be the same I. So you create, like in a while loop, the way you create a permanent variable, you create a condition, and you increment. That's all done in one line for a for loop.
I just want to add something. So you might be wondering when you should use a while loop versus when you should use a for loop. So one thing with the for loop, you kind of need to like give it a range or something. So that works pretty well when you know how many times you want to run something. But a while loop, like especially if you're working with like the user and asking them to put in things, you don't know how many times, like I believe you coded like get a number guessing game. You don't really know how many times it would take for them to get the right answer. So you can't, if you were to try to do that with a for loop, you don't really know what range to give it because that could be different each time. So that's like when you would want to use something like a while loop.
Yeah, so do you want to just show them some examples?
Yeah. Uh,
And remember, you can always like pause.
okay, so I'm just gonna use the primes list that we made before. So 2, 3, 5, 7, 11, I believe. Okay, so um, let's so if we wanted to, let's say we wanted to print everything in this loop. So we can say for I, actually this wasn't in the loop list slide, but I think it's really useful. So I'm just gonna show you real quick. So one thing you can do with a list is you can get the length of the list with the keyword len. So len primes. So all that is the length of the list. So how many things are in the list? And we only have 5. So if I run that, will it work? Yes, so 5. That's the length of the list. So sometimes if you don't really know how long your list is, you might want to use that. So what I'm going to do here is for I in range, we can use 5 or you could use len. I'll just do 5 because we know this is only 5 things. And as Christina mentioned, this range thing, it will only take you from it'll take you from 0 to the range -1. So it doesn't include this number. So it'll go from 0 to 4. And if you remember from before, it would stop here and you wouldn't have to worry about like going like off the end of the loop or anything like that. So let's say we wanted to find, um, let's say we wanted to find like the sum of all these numbers, just combining the different things. Okay, so we have our sum is 0, and we want to go through everything in this list, and we want to add them all together or something like that. The first time this loop runs, it would be 0. So that would correspond to this index. So we want to add. So just remember from the list slides how we access one particular element. So we would do primes, and then we have our brackets. And this might seem a little weird, but since I is going to take all the values from 0 to 4 at some point, we're actually going to index at I. So just keep in mind that I is really just a number that is increasing once each time. So that's actually our entire code. So basically each time the loop runs, it will add that particular element to the sum, and then we would have our sum at the end. Sorry. Okay. And it'd be 28. Okay, so something else you could do with loops. Let's say we had a string, like hello equals hi, how are you? If you wanted to like loop through this, so this was like Christina, are there slides for in, like not in range, but like in?
I don't think so. So I would go over that, yeah, because we use it in
Okay.
the lab.
So let's say we wanted to like go through this list individually. So behind the scenes, um, you can index strings similarly, I believe. So if I were to do like, oh, I gotta print it. So print like hello 0. it would print this. And if I print like 1, then it would print high, like the I. So strings act pretty similar to lists in that you can access individual elements. We can also, you can do the same, similar, what's the word for it? I think it's like splicing. You can take like a whole chunk of a list as you can with a string. So like this would go to U and it would just go to the end. So this should print U. So that's something useful you can do. And similarly to what we did before, if we want to, instead of using range, sometimes we don't really want the index, but we want the value in a list instead. So you can actually do something like this for value in hello. And this will go through the entire thing and it'll take on these values like one at a time. So like the H, then the I, then the comma, then the space, then the H, then the O, and so on. So I'm just gonna do this with the primes case again. So let's just do the sum thing one more time, but just with this different method. So if we wanted to do the sum, instead of having I loop through the indices of the list, we could actually just get the values directly from the list. So Python is really good for like using this. It like makes sense what it's doing. It's just saying for like value in primes, like that makes like pretty good sense. It's going to take each value. So then we could just do sum plus equals value. We don't actually need to index the list. And then if we print sum, we should get 28 again. Yep, so it does the same thing.
Yeah, and just to go over like when you should like really quickly to add like when you're using like for value in primes, you don't want it's when you like you can't edit the list by like trying to edit value, but if you use indexing, then you can actually edit the list.
Right, because if you're trying to like change the list, you need the indices. So like for this, if you know you don't need to change anything, you literally just want what's ever in there, this might be a little bit easier to do. Is there anything else I should add for lists? I mean loops, for loops.
I think you're good. You showed the 2 types. Does anyone have any questions? Feel free to just unmute or type in the chat. Okay. If not, we can just go back to the slides.
Is there a way to block comment in Python? I think it's like that. Oh,
I think like
okay.
3, or you can just highlight all of it.
Oh, I already did that. Okay.
Okay.
Why is this there? Okay. Sorry, the Zoom bar is blocking my tab. Okay. Okay. So functions are also another really useful thing you have in Python. Sometimes you need to run the same piece of code many, many times, but let's say you needed to write something or you needed to run the same code like 1,000 times. Do you really want to like type the same exact code over and over again? Or would it be nice if there's a way to like store it and then use it whenever needed? So that's really what functions do here. And if you think about like math, it's like a really similar concept. Like if you have like f of x equals x squared, and whatever you like pass into this function, it will return that value times itself or squaring it. So as you can see here, this is how you make a function in Python. We use the keyword def, which I believe is short for define, and then you put your name. So instead of square, you could name this whatever you want. And then you have to put parentheses here. What goes inside of these parentheses are something called parameters. Basically, if you think of like f of x equals like something, you need to give it a value of x in order for it to give you a number back. So you could think of that. You could think of that as like what goes in here. Like we want to give it X. However, you could also give it more than one parameter. You could say like X comma Y, and then it would need an X value and a Y value to give you your result. So then once you make that, similarly, like if you were doing a loop, you need to put a colon at the end, and then you need to indent code, and whatever is in that indented chunk is what is a part of this method. So our result is X times X. So the user or yourself would pass in X, it will calculate X times X, and then you use this word return. You will return something, though methods do not necessarily need to return something, but here, if we're squaring a number, we want to get the result. So we return that result. Basically, what that does is it'll like give you that value. So you can like, you can assign the output of this uh, to that to the result of the function, and that's shown here. Like 25 equals square 5. So if you didn't put return and you had this same line, then we wouldn't be getting the number back because this method isn't returning the number. Does that make sense? Any questions about that? Okay, I'll take that as a no. So these are some of the things I went over. So def is the keyword we use to define a function. And we're defining something called square, which it takes a parameter called x. This is the code. The indented part is what is run in the method, and return is what we give the caller. So what that means is when we evaluate a method, or like when we pass in something to the method, that is called calling the method. Or sorry, I keep saying methods. Methods are the same thing as functions. So then we can call this function whenever we want with, like, for example, square. We can give it whatever number we choose, and we will get our value back. Any questions about that? Okay, Christina, do you want to do some examples?
Sure. So we could say we want to make like a computing function that just really quickly like adds or subtracts stuff for us. So like Vignesh said, we would just have our keyword def function name. We could call it like compute. And then we would want parameters. So every time we run this, we would need two numbers. I'll just call it them num1 and num2. And then we'd want an operation. So I'm just gonna use a semicolon, a colon, enter, and then indented code is what is run. So you guys learned like about program flow last time. So we can say if operation equals, let's say we want the user to give us either like a plus or a minus in string form. So we can say if they give us a plus, we want to return the sum of the two numbers. But if they give us a minus, we want to return the difference of like number 1 minus number 2. And then else we could say like return, we could just, if we do return, it's going to return like null or none, which we can interpret as an error when we're actually using this function. So then we can call the function just so right now you're going to see like this does absolutely nothing because like everything is commented out, and this is just the definition of a function. But if we were to use the function, we could say, we could compute like the sum of 7 and 3, and we would give it a plus and a string. And this wouldn't do anything unless we printed it. So we can see that this should return 10. Right? So we can also say, I want to define the difference of something to a variable. So I'll say like 91, 12, and then I'll give it a subtraction symbol. And then this won't do anything. I can print difference. I can do something else with difference. So you'll see it output 79. Just for fun, we can say print compute difference 10, and we'll give it a character that it wouldn't recognize or it wouldn't know what to do with. So this should print out none, as you can see here. So yeah, that's a basic function. I mean, does anyone have any questions about that?
Okay, just gonna add something. So, as Christina showed you, this is like a pretty useful thing. You might be like, why do you need such a simple method just to, like, add numbers when you can just use plus? But the idea is that you can make pretty like complicated things with methods. Obviously, like something more useful that can be run like many times, or if you ever like were making something for a user, like something like complicated like that is like really involved, it makes it really convenient for you to just use this. Like you can see like these print statements, it's just one line to like call the method, as opposed to like copy pasting the entire chunk of code again. So it's pretty useful. Okay, should I go to the next topic?
Oh yeah, sure. If no one has questions.
Does anyone have any questions before we move on? Nope. Okay.
Yeah, if not, so we're going to go over dictionaries. So dictionaries are kind of like lists, but instead of accessing it with like indices like 0, 1, 2, you can use any type of key to access a value. So for example, you if like this dictionary called stuff, we instead of accessing like index 0, we could access the string fire and we would get its value. So we'll go into more detail. Okay, there was a question. So return is basically, if you want to go back to the function slide, Vignesh, sorry. Basically, it lets you, instead of like doing an action, it's gonna say whatever, like this 25, right, is the caller. So whenever you call square of like x, whatever, the return is what like that function is gonna give you. So I don't know if that was clear, Vignesh. You want to try?
I think that's the basic idea of it. So, I guess it's not so easy to give a good example of a method that would use returning like more effectively. But basically, let's say your method is like computing a bunch of different numbers, or like maybe you're doing like a really complicated like computation and there are like many steps. So like let's say there's like three steps. Like you got to process some numbers, and you get one number, process it again, you get a second number, process it again, and then you get your like final number. Return is basically like you could use it to be like, okay, when the user calls this function on some numbers, we're going to give them this number as opposed to something else. So like we have here, it says 25 equals square 5. It's basically the value that's like that like is given back like once the user calls it. I guess if you really want to make the connection, you can say like, if you call a function, the function can like pick up, I guess, and respond with like the return value. So it'll basically be giving that value to like the variable that you are assigning this to.
I think that covers it pretty well.
Okay, hopefully that makes sense. Okay.
So back to dictionaries. So the way you define it is kind of similar to a list. You would have your variable name or your dictionary name, an equal sign, and then you would use curly brackets. So this is just defined across multiple lines to make it easier to see. But within the curly brackets, you have a key, a colon, and a value. And spacing doesn't matter. And keys and values can be almost anything. So you can see like the first one, we have like a string, colon, string. Second one, string, colon, integer, string, colon, boolean, integer, colon, string. So dictionaries can really be made up of multiple different types of variables. Yeah, so if you want to go to the next slide. So just like a list, dictionaries have different methods or functions. So if you take the dictionary name dot keys, it returns you something kind of like a list that you can loop through. So if I say like for I in stuff dot keys, it's going to take me through each of the keys of the through each of the keys of the dictionary, and it would loop through them just like you could loop through like the indices of a list. And you can turn it into a list by using the list method, which we'll show you right after. But you can also loop through the values of a dictionary, which is like what you access using the keys. So again, you can iterate through them using a for loop. And items is basically iterating over both keys and values. It gives you kind of like a list of lists where your first value is your key and your second value is your value. And it just gives you a bunch of those pairs.
Mm-hmm. Oh wait, Christina, do you want to start doing the code along now, just so we finish in time? I think we'll probably cover some of these things there too.
Okay, I think dictionaries might have been a little confusing, but like it should make sense in the lab. Okay.
Okay.
So do you
Okay,
want to
are
just
we
like,
gonna put it here or?
yeah, so we're just gonna, if you guys want to make a new REPL for this, feel free to, just to save your notes for this, or you can just go and comment this all out. You can do that by highlighting everything and then pressing Control / and it'll turn everything into a comment. So Vignesh, do you want to just delete this?
Yeah, sure.
Okay, so just, and do you want to give them like a quick demo
The file.
of what we're making? Yeah. So we
Uh,
wanted to make a cipher because it shows you guys like a few, yeah, shows, yeah. It shows
okay.
you guys a few different applications of the code. Yeah,
Okay,
so basically,
so the idea is that we want to encode or decode a message. Okay, so E is basically just saying, okay, we want to encode. So like, hello. Yeah. Okay, so that's this. So it's been decoded. I'm sorry, encoded. And then let's say that we want to encode or decode another message. So we press Y. Okay, so let's say we want to take that encoded message and then decode it so we can read it again. So we press D. So it tells the program, okay, we want to decode something. And then we just type the same thing in again and it says hello. And then if we press like N, it would just say no, and then the program would end. Okay.
so for this, you can see on the left we had an extra file called cipher.txt. So we're going to also cover like reading information from a file. So I'll just put it in the chat so you guys have it.
I'm gonna demo like bringing it in as
Okay,
well.
so if you guys check the chat, download that file. So Vignesh is going to show you.
Okay, so click download, put it wherever you want. I'm just gonna put it on my desktop. And then once you do that, you're gonna click add file, or sorry, my bad. You're gonna click
Yeah.
these three dots, and you can click upload file. Basically, you find the file on your computer and then put it there. So now it's here. So yeah, do you want to talk about like what this is, this file?
Yeah, and we'll just give them a few moments. If you don't know where your file like went, when you download it, like keep File Explorer open, and you can also just drag it in if that's easier for some of you. So while you guys are doing that, we basically just, this is going to be our cipher. So whenever someone gives us an A, we're going to replace it with a Z, and then B will replace with a Y. So we'll read text in from this, and we'll turn this into a dictionary, where A is our key, Z is our value, B is a key, Y is the value, and so on. So our goal will be when we're encoding, we'll use the keys and get to the values. When we're decoding, we'll have a reverse dictionary and then get the kind of do it in the opposite way. So
Hopefully you've all been able to get the file in here? Okay, we should start, right?
Yeah, probably. Do you want me to start, or do you want to?
You can start.
All right, so first of all, let's make 2 dictionaries. I'm just going to call this edict. Oops. Oh, God. And I'm going to call the other one dictionary. You guys can see. So one will be encrypting, one will be for decrypting. And basically, how you read from a file in Python is basically we can say like, I'm just going to create a variable called file, and I'm going to set it equal to the actual file. So we're going to say open. You're going to say file name, and it defaults to reading. But just to show you, you could do like reading, writing, like W for writing. So we're going to just keep an R because we only want to read the file. So then we're going to create a for loop. And we want to loop through every line in the file. So I'm going to say for line in file. We want to, and it automatically does that. Like even if I use a different variable name, it would go through every line in a file. So if we're looking at the other, if we're looking at cipher.txt, each key and value is split by a colon. So we want to.
You can see here.
Yeah. So we want to make a list of every line, and we can call it. So we can call it line list and say line.split by the colon. So this is a really useful method you can use on strings. So it's going to basically split it into a list where index 0 is going to be like A and index 1 is going to be Z, and it'll just get rid of the colon. So then what we want to do is we want to set edict, we want to set it of the line list of 0, and we want to set it to line list 1. So what this will do for every value, it'll take the key of that line and set it equal to the value of that line. So like A will be set equal to Z. And something important to do is to do dot strip, because sometimes there's extra white space, and we don't want it coming out with like in a whole extra line. So dot strip just gets rid of white space, and white space is like spaces, enters, and things like that. So, and we would, for D dictionary, we would basically do the opposite. So we want to take line list 1 dot strip and set it equal to line list 0 dot strip, if that makes sense. Does anyone have any questions for that? How does that keep happening? Okay. Do you want to start on like a while loop or functions?
I'm gonna do the function. So now we have loaded our dictionaries as Christina just showed you. So now we want a way that we can take our like English message and then convert it to like the encrypted one. So encrypt. So I'm gonna make this method called encrypt, and it's gonna take a message. And similarly, I would make one. Don't forget the colon when you make a method. And then similarly, we would need, sorry, that's supposed to go over here. You would need a decrypt method as well. So a message is going to be supplied by the user, but we'll get to that in a sec. So we're going to need a new message. So we can just call that this, and we're just going to send it, assign it to the empty string. So now we want to take our message, and for each thing, like each letter in our message, we want to get the encrypted letter instead. So what we're going to do, so here's where our loop comes in. So for like letter in message, so this will loop through all the letters in our string. We're going to okay, so so this is encrypting, so we're going to be using our encryption dictionary. So we're going to add to our new message that will be returned to the user. This is the way you can add strings. I think they probably just told you that you can use plus equal. So we're gonna go edict, and we're going to ask it to give us the encryption letter for the letter in the message, which it loops through.
Do you want to use dot get? This way, if
Okay,
it's
yeah,
like a
yeah.
space or an exclamation point, we can just say like dot get letter.
Wait, is it? Yeah, dot get letter.
So basically what that does is if letter isn't an index of the dictionary, you'll give it, like, we can say comma letter after that, and it'll take that as a default value. So it's just gonna, if it doesn't recognize it as an index, it's just gonna keep whatever's there. So yeah. So after letter, just add comma letter. For
okay. Okay, sorry, there's so many spaces now. Okay, so this is our loop.
Sorry, I don't think we capitalized message, like dot upper.
Oh, yes. Okay, message equals message dot upper.
Yeah.
Okay, good.
Yeah, sorry.
That's okay. Okay, so now we have the new message here. It's the letters should be swapped according to like the encryption dictionary. So then we can just return the new message. Hopefully this makes sense. Basically, whenever the user call, or like when the code calls encrypt, it will be giving them the new like encrypted message. Just for the sake of time, I'm gonna copy paste this into decrypt. So the idea is pretty similar. The message, this is gonna be encrypted already, or at least that's the hope. If the user puts in something bad, it might not like be proper. But anyway, so this is encrypted. So we're gonna go through everything in the encrypted message, and we're going to basically do the opposite. We're gonna go into the decryption dictionary, and we're gonna get the regular letter back, and then we would just return this message again. Okay, this looks right?
Yeah, I think so.
Okay, do you want to do the while loop?
Sure. Okay, so we want basically this to go, in the end, we want to be asking the user, like, do you want to play again, or do you want to like encode another message? So for that reason, we're just going to create like a Boolean called encode again. And for now, we're going to set it to true. And then we're just going to say while encode again, because later we can say, oh, if they answer no, we'll set that to false. So we're going to say, we want to know if they want to encode or decode something. So we'll say select encode or decode, and we can say E or D. So we're hoping the user enters something valid, so either an E or a D. But if not, we can say while their action does not equal E, and action does not equal E, we can say, we can say the same message again. So we can ask them for the letter, and we can just add like invalid select encode or decode. So once they do that, you guys went over last time, hopefully, like if else change. So we can say if action equals E, then we want to run, then we want to say, okay, so then we'll want to print out using the, what's our function name? Encrypt, okay. Encrypt. And we want to give it a message. So right now we don't have a message, so it's going to give us an error. But just to show, so this is either E or D, so it's okay to do an else here because we already checked for that. So if you guys can see that. So right now we don't have a message. So above this, we're going to say message equals input. And if you didn't know what input does, is it's kind of like print. It's going to print it out, but it's also going to wait until the user types something in. And then whatever variables here is going to take the value of what the user typed in. So we're going to say something like, please enter a message. So once we have that, we'll have a message, and then we'll be able to pass that message to our functions, which we defined up here. You want to just do the ending, or should I really quickly do it?
Just keep going. You're almost done.
Okay. So we can also say your user input and say, like, do you want to, like, would you like to encrypt/decrypt another message? And we can put, like, in parentheses yes or no. So if user input equals yes or equals a y, we can say we can set encode again equal to true, which is the variable that's making this loop continue. Otherwise, if they enter anything else, we're just gonna set encode again to false. Oops, sorry. And that will break the loop. So if you want to run this, and we'll see if we have any errors, because we kind of rushed through that.
Yeah, okay, so E would be encrypt. I'll just put hello again. Okay, so it's looking good so far. And then we wanna, again, so then we're gonna try decrypting this. Yep, so it looks pretty good. And it'll just keep looping until you don't want to do it anymore. So then, yeah.
We went through that really quickly. Does anyone have any questions? Okay, I see a few questions in the chat. Sorry, we're getting a little overtime. I'll just cover it. Okay, someone's asking if we could go up in the code so they can take a picture.
Oh, yes, for sure.
A repo link, guys, if you want to.
Oh, yeah, that too.
Okay, so yeah, Cipher, it's basically all we did was change an A to a Z, a B to a Y, and things like that. Yeah, so there have to be two equal signs because when you're using two equal signs, you're checking if it's equal to. When you use only one, you're defining something. So does that make sense? Okay. So yeah, so basically two equal signs is checking if something is equal to it. The link to the recording. Okay, that's the Cipher text. We can give you guys a link to this REPL that we used. And if you all know how to fork, do you want to quickly show them, Ignash?
Wait, how to what?
How to fork a REPL? Like if you click the pencil,
the pencil.
And if you get onto that, guys, instead of editing ours, you can click fork. You see it right there, like bottom left.
Wait.
You see like on the bottom left?
Like the bottom left.
Like on the little
oh, yeah. Sorry, the zoom thing was in the way.
Yeah. So if you click on fork, it'll make a copy and you can edit it. It'll be your own. And you'll have all the same code. So the YouTube link, I can quickly get it. If you don't need that link, you don't have to stay. Oh, here it is. Here's our YouTube channel. So this will be up. Okay, thank you guys. Does anyone have, yeah, you're free to leave, unless you have questions. Bye, thank you all.
Okay.
Yeah, stay on if you guys have questions. If not, you can leave. Do you want to stop the recording, Vignesh?
Yeah. But I need to stop sharing too. Okay.